In this video, I am going to estimate multiple linear regression models involving categorical predictors in R programming language. In this video, I am going to use a data set that is known as HSB2. HSB2 is known as a High School Beyond Survey, and it has a number of variables. So before I do this in R, let me share with you some of the description regarding simple linear regression as well as multiple linear regression model and the various assumptions associated with these models. These are the various assumptions of the model, and under these assumptions the output or the estimated results of the regression model will be okay. Otherwise, if any of these assumptions is violated, then we may not report the estimated results of the multiple linear regression model. So these are the various scatter plots that usually we have in R, that is residuals versus fitted values of the dependent variables. This is used for assessing linearity and homoscedasticity. Ideally, the residuals should be scattered randomly around 0 with no distinct pattern. Then we have normal QQ plant which is used for checking normality of residuals. Then we have scale location scatter plot, and this is used to examine the homoscedasticity of residuals. Finally, we have another scatter plot, and that is of residuals versus leverage, which is used for identifying influential data points that might disproportionately affect the model's results. So let me go to R. This is R. I have already downloaded the data set HSB2, and as you see in this data set there are 200 observations of 11 variables. So it means there are 11 variables in this data set. First one is ID code, then we have female, 1 stands for female, 0 stands for male. Then we have race, there are 4 categories. Then there are socioeconomic status, 1 for low, 2 for medium, 3 for high. School type, 1 is for public and 2 is for private. Program, it has 3 categories, 1, 2, 3, that is general, academic and vocational. This is reading score, this is writing score, this is math score, this is science score, this is social study score. So there are 11 variables, and this data set has 200 observations. So what I'm doing here, first of all, I would like to show you names of the variables that are used in this data set. So these are the various names of the variables starting with ID up to social study. So there are 11 variables. In the original data set, there is a gender variable which is categorical, and it is equal to 1 if female and 0 otherwise. So 0 stands for male and 1 stands for female. So I want to convert this categorical variable into a factor variable which I call female.f, and this is the command for converting these numeric codes which are in female variable. When I will convert it to factor variable, then 0 will be replaced by male and 1 will be replaced by female. So let me run. Let me click on run. So this variable has been generated. So let me show it to you. Previously I had 11 variable, now I have 12 variable because I just generated a new variable, that is factor variable. And in the original variable female it is 0, but in this in factor variable it is male. Here it is 1, and here when I converted this into factor variable it is female. So I created another variable which is a factor variable, and it is labeled as male and female instead of 0 and 1. After this, I would like to convert to other categorical variables into factor. One is school type. In school type there are 2. One is public and another one is private. So I will convert this into a factor variable, which will label 1 and 2 as public and private respectively. So this is being created. Similarly, I can also convert socioeconomic status as a factor variable, and it will have 3 labels: low, medium and high instead of 1, 2, 3. So click on run. So it means I created 3 variables. That is why instead of 11 I have now 14 variables in this data set. After this, I would like to run a multiple linear regression model in which science will be my response or outcome variable, and I'll regress score of students in science on their score in math, their score in reading, their score in writing, and then on factor variable female and male and female, and then factor variable a school type. So if I click that, it will run a regression variable. So it gives me these plots. So this is scatter variable between science and math. This is scatter variable between science and reading score, and this is a scatter plot of science with right, and all these 3 scatter plots show that there is a positive correlation between science and math and reading and writing. Regarding male, female and science score, it shows that there is a negative correlation between science and female. It means that on the average, female student has less marks than male students. So let me share the results of this model with you. Here is the output, and it starts with this command. So the data frame is HSB2, and this is the response variable sans. These are the predictors or independent variable. Total number of observations, as I mentioned earlier, are 200, and all of them have been retained. There is no missing value. These are the estimates of this multiple linear regression model. The intercept or the constant of this model is equal to 9.224, and the math, reading and writing score has these coefficients, and these coefficients are highly significant. So it means that science scores is affected by score in math, reading and writing in positive way with highest statistical significance. So far as this coefficient, so how can we interpret this? This means that keeping other variables constant, for every 1 unit increase in math score, the science score increases by 0.28. And similarly, keeping other variables constant, with every 1 unit increase or 1 mark increase in reading score, science score will increase by 0.26. Similarly, keeping all other variables constant, for every 1 unit increase in writing score, the science score will increase by 0.31. This is the coefficient for gender variable. Since female means it is equal to 1 and male it is equal to 0. So minus 3.575 is coefficient for the factor variable female. It means that on the average the female student got minus 3.57 marks less than male students. So the sign is negative. So for female, this intercept will be less than male by this. So 9 minus 226 minus 9.226 minus 3.575, because this coefficient is a negative. Similarly, regarding the school type, for private school, in private school the student got on the average 0.5 to 4 marks less than in a public school. So this is the interpretation of the coefficients, and all except the school type are significant coefficients. So it means that there is no significant difference between science score both in private and public schools. This is the standard deviation of residuals, which is also known as a root mean square error. The lesser the value, the better the model. The R squared for this model is 0.52, adjusted R square is 0.516, and the press R squared is 0.498. And below here we have F stat, and since this p value is very little, less than 0.05, so it means that the overall equation or the overall model is significant. This is the ANOVA. This is a regression sum of square, or model sum of square, or explained sum of square. This is a total sum of square. So this divided by this is equal to R square that we mentioned earlier. This is the unexplained sum of square or residual sum of square. So if you divide this by this score, we get 1 minus R squared. This is the correlation matrix, and down here we have tolerance as well as the VIF. Since there is the VIF score is not greater than 5, so we don't have any issue of multicollinearity. Similarly, none of the tolerance score is less than 0.2, so we don't have any issue of multicollinearity in this model. This is the best